So, welcome to the last technical and AP Math session on the Sharp EL-W506T for 2022. We're going to cover quite a few tips and tricks and some fun things to do on the calculator, particularly relevant to technical and AP Maths. So, take a look. So, the W506T was also developed with the CAPS and the AP Maths curriculum in mind, as well as the technical maths curriculum. It's got some amazing new functions, and so I'm very excited to share them with you tonight. Now, lots of great free resources. So I've recently been introduced to desmos.com. If you haven't heard of it, it is a graphical tool just like GeoGebra. It's also free. What makes it really cool is that you can download it to your smartphone. And so if your students have a tablet or a smartphone in the classroom, you can then explore graphs using desmos.com, which is pretty cool. Then, of course, remember to check out Maths at Sharp for your free grade maths, free grade 8 to 12 maths worksheets. And then, of course, there's our YouTube channel. And if you want to download the Sharp graphical calculator, this is the link here. It is free to download, just like our simulator is, which is this link over here. I'll share this presentation hopefully tomorrow with you when I send out the link to all of the YouTube videos. And then you can just click on these links and download the graphical calculator as well. So, some quick basics for you. Obviously, the on button. Second function is the orange button, and it activates all of your orange functions. Alpha activates your blue functions, so we're talking statistics and memory keys here. Your integral and differential also are activated by alpha. Your mode button gives you access to 9 different modes, and I'll walk you through those in a minute. And then, of course, underneath mode is a button that says BS, and that is for backspace. And then, of course, underneath BS over here is a button that says change, and that just changes your answer from either a third or a mixed number fraction to an improper, and then to a decimal fraction as well. And then, of course, you have your equals button, which will give you the solution if you type in everything. All right, so the different modes that we're going to cover today are all in this list here. So normal, where we'll do things like fractions, probability, trigonometry. We'll do statistics, both single data statistics and linear regression. We'll look at tables and how you can use them to teach finance and factorizing. And then, of course, your complex number calculations. Well, and then your equation solving, which is where you input your coefficients for your equation, and it will give you back your roots. We'll also look at matrices on the calculator and how to use them, and then the vector distribution and drill we're not going to cover tonight, but go take a look, particularly if you're teaching grade 8 and 9 students. The drill is a great way to practice your mental maths on the calculator. So some new functions. The first one is prime factorization. And so what you'll do is you'll just type in a number on the calculator, press equals, and then say second function and exp. You'll see in orange above it, it says pfact, and that will break it down into the prime factors of that number. So that's a nice new addition to the 506. You've also got the highest common factor and lowest common multiple. So here you can type in any pair or set of numbers, so anywhere from 2 to however many numbers you need. Press second function and 2, and that will give you GCD, which stands for greatest common divisor, which is the same as highest common factor. Type in the next number and press equals. Now, what's really nice here is you can put as many numbers as you can fit into your characters on your screen, so to find your highest common factor. So I assume most of the time we don't need more than 4, but you've got space for up to 60, depending on the size of your numbers. Of course, you also have an LCM function. So that would just be second function and 3, and then 72 equals. And then, of course, again, you can add as many numbers as you would like to find the LCM of, and it will then find it for you. So it's really nice, especially when we're talking about adding algebraic fractions, when we talk about finding the LCD. This is a good way to explain how the lowest common denominator is found and to check that they're actually getting the right answer. All right, great. Then, of course, you also have, for the particularly for technical maths, you also have a recurring decimal function on your calculator. So if you had, for example, this, and when we press equals and we change the answer, you can see that it's a recurring decimal. So we can actually set up your calculator by pressing second function and math. You'll see in orange it says setup, and going to number 5 for recurring decimal, and then pressing 1 for on. And now when I change it, you'll see it gives it as a recurring decimal as well as the standard decimal format as well. So that's also a really nice one for grade 10 technical math students as well. Now, if you haven't joined one of our workshops before, and well, if you have, I apologize for showing this again, but if you haven't, this is a really cool trick. It's the teacher shortcut class marks. Okay, so for example, if you set a test which is out of 80 and you want to convert all of those class marks to something out of 100, what you do is type in 100 at the top, press your down arrow key, type in the total that your test is out of, so in our case it's 80, and then press times, and you put your first student's mark. And so say Sepal got 63 out of 80 and equals, and he gets 78 and 0.75, or basically 79%. Now for your next student, all you would do is type in the mark and press equals, and it will give you the correct percentage. And so for the rest of your class, all you're going to do is say mark equals, mark equals, mark equals until you are done. So it's a very nice time saver, particularly for marking exams. So remember to come back to this before you start marking your exams. And remember, you can also show this to your fellow teachers who are not maths teachers. So this function actually works on any Sharp desktop calculator, or any Sharp calculator, in fact. So for these steps, you would say where you're going to divide it by where you've come from equals, and then times the mark equals, and then of course mark equals, and it will give you the same functionality as well. Now, for technical maths, we look quite advanced into, for grade 12, into the different logs. So just to show you quickly on the calculator, you can input logs in 3 different ways. The first is when you have a log with a base 10, so you just press the log and whatever your number is, and then you have a log with a sorry, let's do them individually. You have a natural log, which uses base E. So while we don't necessarily cover this in high school, we do cover it in university. So it's a good thing to know about. Okay, and then of course you have a log where you can input your own base. So that's just second function and pi, and that let's make our base 3 this time, and 81. And just equal. So you just use your arrow key to shift between the different parts of the log. Cool. For grade 10 technical maths, students also need to be able to convert between binary and decimal numbers and do some basic binary calculations. So very easy to do on the calculator. Let's say, for example, you have 253 and you want to convert it to binary. You would just say second function and your divide key. You can see above it in orange, it says arrow binary, and that will just give you your binary number. Now, you can do binary calculations. You'll see if I try and press any other numbers, it doesn't work. So it's only the 1 and the 0, not even a decimal point. And equals, and that gives us this answer. To convert back to our decimal notation, we would press second function and our equals button, and you'll see above it, it says decimal, and that will give us this answer here. So, awesome. Any questions so far? We're all still good. Remember, you can pop them into the Q&A function and I will answer them. They'll show up on my screen and tell me I have a question. So, okay, so let's talk converting radians and between degrees of radians, which you need for both technical and AP maths. So, let's say, for example, you have 60 degrees. And you'll see that your calculator is automatically set to degrees. So when we do this, we would say 60, and then you would press second function and your decimal. And what it does is it converts it to radians for you. Then you can input radians, let's add a pi over there, and converts it back to degrees by saying second function dot, and gives you gradients, and then the second function and your decimal again, and that will give you your degrees. Now you can, as a shortcut, store into your user-defined keys. So these are D1, D2, D3. They're just shortcut keys. You cannot save a formula or anything like that. You have to save a function that's already part of the calculator, just one that requires more 2 or more buttons. Okay, so here we're going to just say second function and your degrees function. And so now what happens is I have it in degrees, and let's say I have 80.32 degrees, and I want to convert it now into radians. I would then just press radians, the D1 button. And so all it's doing is that second function dot step for you when you press D1. Okay, so there are several examples that go along with this. I just want to show you the degrees, minutes, seconds example, and share both screens with you so that you can see. So here, this last one, we have 110 degrees, 24 minutes and 6 seconds. So to input that, say 110 degrees is DMS, 24 minutes DMS, and 6 seconds. And then of course we would just press D1, and that will give us our radians. Now if we wanted to do radians, so let's say we have 1.5 radians, and when it's converted back to degrees, minutes, and seconds, again D1 twice, and then all we would do is say second function and our DMS button, and then it will give us the degrees, minutes, and seconds as well. So it's a very nice function to have with your calculator. Now, following on from this, there are several awesome functions that you can do with your DMS function on your calculator. So I'll go through those with you. So the first one is simply converting minutes into hours. So say, for example, we have 582 minutes, and we want to know how many hours that is. So we would put a 0 in our hours placeholder, press our DMS button, and then type in 582 and just press equals, and that will then automatically convert that for you. Now, if we wanted this as a fraction or a decimal, we can then simply press second function DMS, and it will convert that into a fraction or a decimal for us as well. The other nice function that you can use with DMS is the how long does it take me to get somewhere. So, for example, if I travel 1,400 kilometers to Cape Town from Pretoria, and I do an average speed of 124 kilometers per hour, gives me 11 hours and something. So then I can press second function and DMS, It gives me 11 hours, 17 minutes, and 25.16 seconds. The other nice function that you can use this for is the how long question. So how long was Susie on the train for? So for example, if Susie gets on the train at 10 to 11 in the morning and she gets off at 25 minutes past 2 in the afternoon, how long did she spend on the train? So we're going to say 2 DMS. Remember to use your 24-hour notation time. So 25 past 2 minus, and then it was 10 to 11, right? So it's 10:50. And we'd say equals, and it gives us 3 hours and 35 minutes. Again, you can convert that into a fraction if you need it, or into decimal, depending on what is required in your answer. Okay, so all the examples are here for you to look through and have a squiz at and follow up tomorrow. Okay, so any questions so far? We're still all good? Okay, great, fantastic. So let's move on to calculus then. Zolani, you fantastic. Okay, great, awesome. I assume if you're raising your hand, it means you're good. Sweet, okay. If you do have a question, just pop it into the Q&A and I'll chat until we receive your question there. Okay, so for differentiation, you would use alpha and your open brackets, and you'll see that you, sorry, wrong one, alpha and your close bracket, and you'll see ddx. And then what you would do is just fill in your expression at the top using your x values. So to make an x, you would press RCL twice. And I'm just going to use the example that's here, -4. And then you would fill in the position of your differentiation. So if I want to differentiate at the point x is equal to 2. So obviously it's not going to do algebra for you. It's not going to give you an algebraic solution. It's using an approximation method to find the solution for you. And that's why you get answers like this, where you have that comma 0.00005, is because it was using an approximation. So that is actually the error that you're seeing with the calculation. So if we did it algebraically, we would get an answer of 32. Now we can also integrate, and we do that by pressing alpha and our open bracket to give us integral. And again, it's your definite integral. So it's between 2 points. So we'll just use 1 and 2 and use the same expression again, x to the power of 4 minus 4, and then equals. And you'll see when it's a very long approximation, you'll see a busy sign. Just be patient, particularly when you work with trigonometry for your integrals, you'll see that the busy sign does tend to take a little bit longer than these smaller integrals, or if you have a very large area that you want to integrate over, or very large space. So yeah, that's pretty much it when it comes to integrals. Remember, if you are using sine, cos, or tan in your integrals and you're working with radians, to change your radians first and then to do your integral. So from, say, negative pi to pi, and let's say sine x, and then you'll see busy 4, you'll see it takes quite a bit longer, but then we've got our solution as well. And then of course you can convert that into degrees if we wanted to. All right. From there, we can look at calculus, graphs, and roots. And I included later on the factor remainder theorem, but I realize it's quite repetitious of what I'm going to do now with you. But let's do this version. So the factor remainder theorem basically says that when you have a factor and you substitute it into your expression, it should give you an answer of 0. If it doesn't give you an answer of 0, it's obviously not a factor. So we can go to table mode by pressing mode and to the table. And then we're going to actually fill in this expression here, or this polynomial. So x to the power of 3 plus 13. Our RCL twice gives you an x. squared plus 34x minus 48. So that looks the same, right? Okay, cool. And then of course we'd say equals and we'd get function 2. Now I'm going to ignore function 2 for now. I will come back to it in just a minute. So I'm going to say equals and you can see start and step. Again, I'm going to be lazy for now and leave start at 0 and step at 1. So I'm just going to press equals twice. And here you can see already that our first factor is x is equal to 1. So when we write this as a factor, we have x is equal to 1. So our factor is x minus 1 is equal to 0. Okay, now if I scroll down the table, you'll see that my values just keep getting bigger and bigger. So I'm not going to find any more factors in this direction. Now, even though we started at 0, you can see that you can scroll up into the negative integers as well. So there's actually no limitation on your table at all. You can go up or down in either direction for as long as you like. You won't run out of space, which is why it's so awesome to use this calculator to teach things like financial maths. And I'll show you a couple of cool things in a few. So let's see if we can find some factors. There we go. So x is equal to minus 6. And if I keep looking, x is equal to minus 8. So here I have x is equal to minus 6. So my factor is x plus 6. And x is equal to minus 8. So my factor is x plus 8. So all of my factors are these here, x minus 1, x plus 6, and x plus 8. Now, from here, what's really cool is what we can do with function 2. So what I've done is I've actually found the gradients by applying differentiation to my original cubic function, and that's this expression over here, 3x squared plus 26x plus 34. And what I'm going to do is, in function 1, I'm going to leave my original graph, and in function 2, I'm going to now put this gradient expression in, right? So 3x squared plus 26x plus 34, right? And equals, and again equals. Now, if I look in this, in answer 2, which is where my gradient is, we can see that my gradient is just getting steeper and steeper and steeper. In other words, it's drawing this line here, okay? Then if I scroll up to my table, I can see that between -1 and 2, my gradient switches from being positive to being negative. So I'm drawing the graph backwards, so it looks like that. And then if I continue up, you'll see it stays negative, but then it comes back and switches to positive again at -8. So here we can see that our graph does this. And then again, it's positive and then negative and then positive. So from our gradient, we can see that our stationary points are somewhere between -7 and -8. And between -2 and -1. So this doesn't look like it's a straightforward, easy one to solve. It looks like it would be a complicated quadratic formula version. But it is nice to be able to say, okay, I can predict from my table where approximately my answer should lie on the graph. So it does make graphing just a little bit easier as well. All right, cool. We all happy so far? Fantastic. Okay, so let's talk through complex numbers, and this is particularly useful for both technical maths and AP maths. You both use complex numbers in your calculations. So I'm going to go home, and home just takes me back to normal mode from whichever other mode that I was in. Now, in normal mode, if I took the square root of -1, what it would give me is an error, because in normal mode, we teach that the square root of a negative number is undefined. Okay, now if I go to our complex mode and I type in the square root of -1, what it's going to give me then is I. So that's just the difference between the two the two different numbers. Now for complex numbers, it's quite straightforward. So you'll see on the side here, you've got x, y, and that just says that you are using rectangular coordinates in your calculation. So if, for example, so in other words, you're using an I value. So we could say 5 plus 3i. And you'll see when you press equals, it breaks it down into the real and the imaginary set of numbers, or separates it for you. Now, you can also then convert this into polar coordinates by pressing second function and 8, and then it will give you 5.83, and your angle will be 30.96. You can also, let me switch back here. So again, you've got your rectangular coordinates. You could also input your polar coordinates using second function and your XY button and putting in an angle, and then it will automatically calculate your rectangular coordinates for you. The other cool thing is if you press math, you can find the conjugate. Not that it's necessary, because the conjugate is pretty straightforward, but it's always nice to check your answer, especially for those students who are nervous. Then you can use that to do your calculation as well. And that's pretty much what complex numbers boils down to. It's quite straightforward. So I'm not going to go any further than that. You can also have your real and imaginary values separated out. But again, I don't feel like it's absolutely necessary when you have the answers being given to you in real and imaginary anyway. All right, so let's talk through trigonometry. So first thing that I want to share with you is a very cool shortcut. Now remember, we used the D1 keys, the D keys, right? What you can do is you can also store into, let's use D2 this time, into your D key, the second function sine, so that now whenever you press D2, the inverse of sine or arc sine automatically comes up, and then you can just type in the ratio. Oopsie, I am still in complex mode. Let me just go home. Here we go. So if I press D2 now and I say half and equals, will give me my angle. Okay, so home is really handy, as I just showed you. What's also cool is you can use Pythagoras in normal mode to find your hypotenuse and the angle that your hypotenuse makes with the x-axis. So for example, if I have a p coordinates, and let's call it 5 and 12, what I can then do is press 5, press your x, y in brackets button, press 12, and then say second function. And now we're going to press 8 to go to r theta. So hypotenuse is 13, and the angle that the hypotenuse makes with the x-axis is 67 degrees. So it's this angle here. So it's your bow tie angle, essentially, that you will be getting. All right, cool. Now, we can also use the calculator to teach the cast diagram. So I'm actually just going to show you my slides because you've seen how never mind. So if I go to table mode and I input a sine graph, just a regular old sine x graph, right? And in my step, instead of making steps of 1, I'm going to do steps of 15, because otherwise this whole exercise will take a lot longer. And then we can press equals. And you'll see that you can scroll through the table. And again, because your table is unlimited, you can go for as long as you like without running out of space. And what you'll actually see is that a pattern forms, and that the same values keep getting repeated, whether they're negative or positive, over and over and over again. So what I've done is I've created a table for you, and I've looked at these values, and I've looked at what the sign of the answer is. So between negative 180 and negative 90, my answer is negative. Between negative 90 and 0, my answer is negative. Between 0 and 90, my answer is positive. and between 90 and 180, my answer is positive. Between 180 and 270, my answer is negative. And between 270 and 360, my answer is negative. Now we can do this for each of the sine, cos, and tan values. And what we'll see is that sine is positive here, and sine is positive here. Cos is positive here, and cos is positive here. Tan is positive in this quadrant, and tan is positive in this quadrant. So here, where they are all positive, we put in an A, and we can actually see where the cast diagram comes from by using our table and our second table, our table of sines, to show where this pattern comes from. And I think it's a very good exercise for students, because often we just give them the cast diagram and we assume that they know where it comes from. And I must be honest, this only really clicked for me in university when I started teaching extra maths to other students. I was like, oh, the graph is infinite and repeats itself. So that's why we can use the cast diagram to predict the pattern, because the pattern is repetitious. So it's a very good idea to share with your students. Now, I'll put in this long example, but I want to get to the point of this example because it is already quite late and I don't want to keep you too late tonight. So what I want to show you, and what's really cool, is actually using the table mode on your calculator to find a specific solution from a general solution. So we solve all of this and we eventually get to these two as general solutions, right? And then what we do is we then say, give me one, there we go, is on our calculator, we just clear that function away by pressing on twice. We're going to put this first general solution in, which is negative 10.53, plus, obviously we don't have a k, so we're going to use x instead, times 360. And then in function 2, we're going to put this second general solution, which is 130.53, plus, again, we're going to use x instead of k, times 360. Okay, and then we'll say equals, and our start we'll make at 0. Our step will make 1, because now we're substituting in k values. And so here we're asked to find solutions between 30 degrees and 200 degrees. Now, if we look at our table, when we substitute a negative 1 for k, we can see that the solution is negative 370.53 and 229.47. So that doesn't fall into our range of values, so we ignore it. Now, at k is 0, we can see that our first solution is negative 10.53. So again, not what we're looking, or doesn't fall into our range, so we ignore that one. But 130.53 is in our range, so that is a specific solution, and we write that. And then our last one, if we put k is equal to 1 into our 2, we'll see that it gives us 349, which is again outside of our range, and 490, again outside of our range. So we now have found our singular specific solution by using the table mode, which is pretty cool. So this is really nice for those students who struggle with substitution of k, and it just does save a lot of time and prevent some mistakes from happening as well. So there were quite a few requests for permutations and combinations across both the technical and AP maths as well as the FET maths. So I just thought, let me just put it in here and reiterate everything. So if you were part of the FET maths, please forgive me for repetition. So the thing about combinations and permutations is which one is which and why does it matter? With a combination, we're talking volunteers. So it's a combination of people who are willing to help with something. So for example, in a class of 20 students, you have 3 students who volunteer to carry your books to your car. Okay, so it doesn't matter in which order they come up, there's 3 of them and they're all going to carry books to your car. If we talk about permutations, we're talking about placing those students into an order. So in other words, first, second, and third place. So they're positional. So permutation is positional, and you have to put the elements that you select into different orders. Thank you, Zolani. I'm glad you like my general solution. So that is the difference between the two. So to look at the difference between the two, I'm going to then go to my calculator and press home. And now you can see on number 5 above it in orange, it says combination. And in orange above number 6, it says permutation. So if we start with the combination, we have 20 students in a class, and we can select 6 volunteers. So it's just second function and 5 to get our combination. Sorry, not 6 volunteers, 3 volunteers, and equals, and that gives us 1,140 different ways that the volunteers can be called up from our class of 20. If we have a permutation, so we have 20 students who've now entered a competition, okay, so they are in a position, then we say there are 3 positions available for them, first, second, and third, and we say equals, we now have 6,840 options. So we can see that permutations give us a lot more options than our combinations do for the same values. So that's just the difference there as well. All right, statistics. Are we all still good, alive, well, breathing, listening, not falling asleep in the dark? Okay, so let's talk, great, Solani, thanks. Let's talk univariate statistics and linear regression. So to get to stats, we're going to press mode and 1 for stats, and then we're going to choose 0 for single data. And what we'll do is we'll just type in some values. I'm just going to make them up randomly. So they won't be in any shape or form. Oops, I've done that one. Okay, now I can see that I typed in a 15, and I probably should have typed in 51 instead. So when you make a mistake and you want to change what you've typed in, what you do is use your arrow keys to highlight the number that you want to change using that little block. On your calculator, it's actually blue. And then you would type in the new number that you want to input and press equals, and it will just overwrite that number for you. So very, very easy to edit your data, and of course to add extra data if you need to. Once you're done and you're happy with your data, you can just press your change button. So change just allows you to change between your data table, or your screen with information, and your screen that's going to allow you to calculate your summary of information. So let's go find our average and all that good stuff. So we're going to press alpha and 8, and then all we have to do is press 0, and that's it. There's n is number of observations, which is 9. X bar is 69.555, so we can see the average is 69.5 or 69.55. Your standard deviation is sigma x is 16.77. The sum of x is 626. And then, of course, you have your 5-number summary. So your minimum, quartile 1, max, median, quartile 3, and of course your maximum. It's really nice because all of your data is on these 4 screens that you just need to scroll through in order to access. So very easy stats, right? Now for linear regression, we're going to press mode and 1 for stats, and this time we're going to choose 1 for a plus bx. Okay, and now you can choose how you want to put your data in. So you can type in all of your x's. So for example, 1, 2, 3, and then go back up and type in all of your y's. Now, I don't like that method because it tends to introduce errors into your table of information. And also because we're talking about a linear relationship. In other words, X and Y are linked to each other. It's important that they belong to together, right? So when you draw the scatter plot of your points, you know, they each have a special someone that they go with. And so it's better in one sense to link the two straight away in the table and to show that relationship with your students. So that's just my 2 cents. Okay, so let's say we have 1 and 6, and then, okay, so what you do is you type in 1, press your X, Y in brackets button, press 6, and then say equals, and the calculator will just fill in that information. So it doesn't add any extra time to your information. If anything, it should save you time. Let's change that to 10, and then let's make this one 3 and 12. Okay, so it's not exactly a straight line, but it's good not to always work with perfect data, right? So once you've inputted your data, obviously you would input more than I've put now, but it will work for this one. Press your change button to go to your calculation screen, and then press alpha and 8. Now, before we used 0, and that just gives us, again, all of our averages, our sums, our minimum, maximum, our standard deviation, etc., for calculations. If we want to find the linear regression line, because I'm sure that's really what you're interested in, you press alpha 8 and you press 1 for regression values. And here we can see our gradient is 3.33, our y-intercept is 3.33. And we can just see that from the line that we're given at the top. And B, our gradient is 3. And we can see that our correlation coefficient is 0.98. A strong positive correlation for the data. And then, of course, our correlation coefficient is here as well, which says that the relationship with X and Y, so Y is explained by 96% X and only 4% by error. So it's quite a nice way to see that. So in Chi, you asked mode. So mode is just mode and then 1 for stat. So you'd press 1. And then to do linear regression, we would choose 1. Now you'll see that because I'll return to the same stats mode, all of my data is still saved here for you. So it does save me a bit of time if I want to go back and check my answers and make sure that I input the data correctly as well. All right, any questions? We're all still good? Okay, so let me just repeat how to do that one quickly. So once you finish typing your data, press change. And then to get your regression line, you press alpha and 8. You can see above it in blue, it says stats. And then you would choose 1 for regression values, and that will give you your regression line coefficients. All right, so let's talk finance. Everyone's still happy and awake? Great, fantastic. I'm not going to go through, thanks, Solani. I'm not going to go through simple and compound interest because I want to do this one, which is the present value annuity. So, and this one is just so much more fun. But you'll see that you can apply simple and compound interest to this as well. So we're going to go back to our table mode. And I'm going to share both screens with you so that you can see what I'm talking about. So what I'm going to do is I'm actually going to fill this expression in here into my function one. So my X is going to be an X. In other words, my payment amount is X. And then I'm just going to fill in the rest here. 1 plus, I've got an interest rate of 10%. That is compounded monthly. And I'm going to borrow that over 5 years and pay it back monthly. And there we go. And that's all over an interest rate of 10% per year, compounded monthly. Okay, so that's a lot of data. Now, I did that really quickly because I spend a lot of time clicking buttons on the calculator. It takes us a touch of practice, but once you get it, you'll see it's quite intuitive and straightforward to understand as well. Okay, so once we've put in the formula, we just press equals. And we're going to ignore function 2. So let's not make it any more complicated than it needs to be. And we're going to make our start 0 and our step as 1. And I'll come back to this in a minute. But it's just a good way to explain what's actually going on with your graph or your table. So what X actually is it's saying that if you're willing to pay back R1 a month for the next 5 years, you can borrow at 10% per annum compounded monthly, 47 Rand. If you're willing to pay back 10 Rand a month, you can borrow 470 Rand, and so on and so forth. Now, this isn't very useful. So what we do is we press on. We can see our expression is still there, so we're just going to leave it. Press equals, leave function 2, so press equals. Leave your start at 0, but this time make your step 100. Okay, so now if I am willing to pay back 500 Rand a month for 5 years over at 10% per annum compounded monthly, I can borrow 23,500 Rand. If I'm willing to pay back 1,100 Rand, I can borrow 51,000 Rand. Now you can also reverse this. So I can say, okay, I want to buy a car and it's 130,000 Rand. How much would I pay back per month using 5 years and 10% per annum compound monthly? Then I'm looking for the value of 130,000. I'll just scroll through my table there. So we can see it's between 2,700 and 2,800 Rand. Now what we can then do is go back to our start and say 2,700, and this time we're going to make our step 10, and then we can really get a nice accurate assessment. So we can see that we're actually going to pay between 2,760 Rand and 2,770 Rand per month to borrow 130,000 Rand. So that's quite a nice way to work through the present, and you can do this with future values and so on and so forth. You can also, of course, go back and edit your expression. So we could go back and say, okay, instead of saying 10%, I'm going to borrow it at 9%, and I'm going to borrow it over 6 years. So it's go. So now you can see we've edited all of the things, and now I want to know how much I would pay at 130,000, and you can see you can borrow quite a bit more over 6 years with a 9% per annum, paying 2,700 Rand, than you could with a 5-year loan at 10%. All right, so the matrices are particularly important for AP maths. So I just want to show you this because it is very, very cool. So I'm going to do this, and then we're going to actually input, I'm not actually going to input that matrix. I'm just going to input a simpler matrix. Okay, so we're going to press mode, and then matrix is 5. So we press 5. To access the matrix and to input it or edit it, we would press math and we choose 1 for edit. Okay, now you have up to a 4x4 matrix, but I'm just going to do a 2x2 just because it will be much easier and faster. So you let me put this one in. I'm just going to put random values in. Okay, now we've got that right. So once we've input all of our values for our matrix, we then need to save our matrix or name it. Okay, so we press on and we say math and we say 3 for store and we name it matrix A. Okay, now let's say you want to multiply matrix A by 3. Okay, so we can say 3 times, and then to call matrix A, we would say math 0 for matrix and then 0 for matrix A, and that will give us our solution. What you can do, and which is a really nice shortcut if you know you're going to be working with the matrix quite a bit, is to store into D1 the name of your matrix. So you're going to press math 0 for matrix, 0 for matrix A, and now when you press D1, you will automatically call up matrix A. So it's just, again, a time saver with your buttons. So if, for example, I wanted the inverse of matrix A, I would say second function, and here above x squared, you can see is the inverse, and equals, and voila. It's as easy as that. It's really simple. If you want the determinant, you would press math, 4 for determinant, and then press matrix A and equals, and it will give you your determinant as well. There are some other really great functions on your calculator. So yes, and you can use this for simultaneous equation, but matrices are particularly used for AP maths. So we don't use it in technical maths at all, but I will show you the equation solver, which works with matrices as well. Of course, you can also find the transpose and the row echelon form, as well as the reduced row echelon form. So let me show you quickly how to do that. So with the row echelon form, you would just press math and then press down. You can see number A, or letter A, is reference. So it's actually your memory key A. So you'd say A, and then the name of your matrix, and that will give you your row echelon form. You can do reduced row echelon form, but with our example, what it would do is just give us an identity matrix. So you can go and try that out using this one to solve, and this is where you would actually solve a simultaneous equation. So you'd have your ax plus by minus 2, or is equal to minus 2, and then 1x plus 7y is equal to 8. And then that's what you would substitute in here, and that would give you your different equation. Cool, it's a pleasure. All right, so moving on from matrices, and this is where this becomes applicable, is to actually use the equations mode to solve for quadratic or 2-variable and 3-variable linear equations. So matrices are 2-variable or 3-variable linear. There's no squares or any cubes or anything like that. So we cannot use it for our grade 11 simultaneous equations for maths, just as a heads up. Okay, so let's do a cubic example. So what we're going to do is press mode and choose 4 for equation and choose 3 for cubic, and then you'll see you've got A, B, C, and D. Now, if I show you my example here on my screen, you'll see it says 7x cubed minus 3x squared plus 8x minus 12. So here in A, I'm going to fill in 7 and press equals. And then B, I've got negative, so use the negative button, 3 and equals. C is 8, positive 8, so it's just 8 equals. And then D is negative 12, so negative 12 and equals. And then you can see we've got one real solution and then a conjugate pair as well for this cubic equation. And then this is the factor and remainder theorem that I mentioned earlier. I'm going to leave it as is for now because we already did cover it in the calculus. All right, great. Any questions for anyone? We're all questioned out. Okay. To those of you who are watching on YouTube, thank you so much for joining us. Please like and subscribe. And if you do have any questions, leave them in the comments below. Cheers for now.